Hello. So let's start. Hello. So let's start. Hello. So we'll be doing some C++ then. Let's get started. So this is my project. I need to add C++ now because it is becoming slow when you're using blueprints. So let's see. So, yeah.
Team match, let's go.
Okay. Now if you play here, that entire shooting part is written in blueprint. Now I have to written it in C++. So let's see how to write in C++. So if you go to blueprints, just a minute. So now what we need to do is we need to convert this entire thing into C++. So let's get started. I will look at the charts after we did it in C++. So where are my guns? So I have to go to pickers and guns. Master, here is our master gun. Okay, it doesn't have any actor. So if you go to my player, and if you go to the UI part, and if you press on this fire, I'm going to call this function character interface attack. So we'll go in here, checking where is attack. So shoot. I'm going to call this function spawn bullet. Now we need this function in C++. That is the main thing. And there is one interface that I'm calling get data per gun. This interface needs to be in C++ as well. So pretty much I need to do this entire thing in C++. Entire thing. It's like a big mess actually. So we'll see how we do it. Okay. So first of all, let us divide this thing into tasks so that we can do it. First, what we need to do is we need to create C++ class for gun. Need to create C++ interface for the character. Then need to write shooting logic in C++. Not many, to be honest. It's not too much. Plus, it's an actor. So next, can actor, something like that will good enough. Connect, create class. I'm pretty much a noob in C++, so we need to switch a lot in code actually. So okay, let me just add a text here. Nice. So let's get started. Here's our connector CPP, and this is a connector. So let's see. Connector CPP, connector.h. Let's see. Okay, so tick. It will never tick actually. So we will set the tick to false here. So how to set the tick to false? Okay. BLO tick before game begin play. You don't have that one. Set actor tick enable. Okay. Set actor tick enabled. False. Okay, it is defined, right? Cool. So we enable the stick. Now what? Now we need to create a function. Let us create a function. Since it need to be called from our blueprint, it should be public. And next, let's see. Void spawn bullet. Okay, if you look here, right? Whenever we call it, we are sending our player as well. So here, the actor, player, maybe reference. Yes, this will be something like that. Create definition and okay. Now we got the definition. And now what? We can just print something. So print string. Okay, where is it in the C++ API? This API is more waste actually. String. Okay, so let's see. Okay, I can do this one, right? Okay, fine. Message. Then calling the spawn bullet function. Alright. Spawn bullet function. And let us build on the building walls. Let us build it. So now go to class settings of our gun master. Just for safe side, I'm going to change it to 1 for not having any name collisions. Now I'll go to here, class settings, gun connector. Oh shit, how does it fail? Oh my god, there is some failure, guys. What is that error, guys? What is that error? What is that error? I don't know. It should be false. And we will see what is that error. Pickables guns master. Now it is working. Okay. Now if you where is gun? Yeah. Here we are calling spawn bullet. What? Keep it one. So now if we go to our player, if you call this guy, and if you go to guns, go to enterprises, guns, call attack, shoot. What the fuck is happening here? Actually, we need to attack, right? Attack, shoot. Okay, here we're calling spawn bullet 1. What I'll do is I'll try to call spawn bullet. Wait, there is no function called spawn bullet here. Why? Okay, got it. We'll make it blueprint callable. So we need to do it, make it blueprint callable. Let's see. Is there any here blueprint read write? Yes, blueprint callable. So keep it here. Blueprint callable category is gun functions. Yeah, it is now project only, build on the building wars. Showing the project settings, close it. Okay, done. Now I can come here and I can call spawn bullet. We can say we have spawn bullet here, and I can pass this player. Cool. Now we can check it out if it is actually working or not.
Team match. Let's go.
Okay, fine, it's working. Okay, now what we need to do? So we need to get the information from the player actually. So this is what we're doing here. We're getting data from the player actually. And camera is firing mesh, everything. And then we're creating this visibility based analytic option. We can ignore most of this stuff. So we need to take care of this. Then we have MO, and so I need to create a variable then, which is MO. MO max MO, I think mostly that. I had to create another variable damage. There is another interface here called fire gun. We'll go by one each step. So here first of all I need to create this. Okay, fine. We need to have a C++ interface. So let's see. Class settings. Okay, this guy is inherited from ALS character PB. So what should I do now? Okay, I think I can just call a C++ interface here. So let's see. I'll create an interface. There's nothing here. I don't know how to create an interface. So we have to check that thing out first. How to create this interface now? This is a weird part actually. I'm not able to find. It is just an empty class, I think, or actor. I don't know, man. We need to find it out really. Okay, got it. U interface, got it. U interface. So let's create new C++ class, and then you need to go to U interface. U interface. Three options. Show internal classes. Nothing. There is nothing. Interfaces. Let's see. Interface class you mentioned this opportunity to implement this various always game might but have no comfort then in this case. Current with the normal was I can show you how. Hmm. This is really weird actually. Not able to find it. Okay, fine then. I'm going to go with the object then. User interface. Niagara. Yeah, only you. Okay, fine. Let me see it from object. Client and interface. I'm getting it at this thing. Then we're going to add this stuff and we'll see if it works or not. Okay, here player. Oh shit, player did interface .h file as well. How do I do a .h? Okay, fine. So, okay, for it to be blueprint, you need to add this. Let's add this U interface, and it should inherit from this thing. So, yep, and then generator underscore body. It is showing some other thing. Generator underscore U interface underscore body. So we'll add this. Body and okay, there is no semicolon here. Okay, now you need to add some clauses here. So we'll add some clauses and let's remove this thing. Okay, and getting data from player data interface knowledge, getting data from player, and what is this? This is a function that we are writing get data. Okay, so what does this thing consist of? Now check if it is firing, if it is scoping, socket name and all. So he is firing, he is scoping, F string, socket name, we need to have mesh as well, skeletal mesh and camera. Where is the mesh? Here we should get some mesh, and here we should get some camera. U camera. Use skeletal mesh component. It should be after before scoping, so here I'm adding it. And then we have camera component. So we need a camera as well. How do we need to have camera? Let's see. I don't know why it is even why I'm using this. It's not at all useful. So let's see. So if I go to my soldier, here's camera component. camera component. So maybe something like U camera. There is nothing regarding cameras. I should check something here. U camera component. It is not giving that. Now it is working. Okay, we added this. This is the API. Bladed interface. This is an interface. Now we can just build it. Okay, failed. Hashtag include found after generated .h. Okay. Failed. Missing extending expected pointer type. Okay. Here. I think so. Failed. U interface plated interface browser without I plated interface. Okay. What do you mean you need I plated interface? This is in C++. Interface declaration. Since the U interface is now the actual interface is empty because there is only visible terminal for each other. The actual interface will be inherited by the others must have the same class name with the U changed to I. Okay. Okay, so we need to have another class here. Oh shit, got it. That is what he is saying then. That is what he is saying when he added two classes here. I thought it is just for fun actually. So we need to do some stuff here. So let's first do these things. And here also they said the same thing. We need to have I here and generated body. So we need to have I and just generated body, and then we need to have whatever functions that we have inside here, instead of the U interface. It's compiling a lot every time. Fuck, it's failed. Bool iPlayer override function not found in iPlayer interface. What is this? Play data interface. I can't see. We have U interface. Just a minute, I think I just need to do U interface, put in data type, U and everything, and it inherits from U interface, and it has something like that. And then we have this thing which uses I, and it creates generate interface body. Okay, Here it is showing something, here it is showing something. Okay, fine, anything is fine, I think so. Wanting your interface in C++. Declaring C++ on interface functions. Public virtual. Oh, I think I need to add virtual, I think so. Public real virtual. I think I need to add virtual. Blueprint event device and interface must not declare virtual. Okay. Then what is the error? The EU previous class needs no construction in but the interface will consider all the interface functions and is the one that will actually be inherited by your other classes. Okay. What is the error that we are getting here? The command here 35 what? See declaration of I player interface. Bool I player interface get player data. Oh wait, what? Your camera component. I think did I save it or not? Overload function not found in. They're saying overloaded function is not found in class using interface. If I remove this thing, right? Let's see if I remove this thing. What will happen? Failed. Unresolved external symbol. So mostly we can keep something like virtual. What the man? C++ is like really huge pain. I don't know how mosquitoes are coming here actually. Okay, let's see. No, I'm going to remove this. I'm missing something, but I'm not able to find what I'm missing. Really. Blueprint type, view interface. We declare the class, and then we declare type layer data interface. Member function not found in I. is the function I want to able to then the function. Dogma 1 must have blueprint as specified to have this interface exposed to blueprint. And this one you can easily add this interface to any blueprint class. Okay. This one has blueprint type. U interface. Generated U interface body. Then I created interface. We have I reacts to time of the day. I added I as well here. There is no concrete exam was public. We have U function. Class using the reverse measurement react to high note. To high note. May implement. Okay. So let me change it and we will see. Not it doesn't make much difference, but I don't know. We can check it out. React to midnight. Change it to generation. Whatever we change. Version of this too. An observable CPP. Okay, here we have it. Okay, got it. Using it with C++ color. So we have to go to C++ then as well. Yeah, I forgot to do that. I think so. So this is what we had until now. What is my project.h? I don't know. I don't know what is my project, to be honest. You created interface. You created interface of object initializer. Yep. Now let's see. Shit, man. What is error? Function not found. Overloaded member function not found. In I created interface. Created interface it's 24. Overloaded not function not found. What is this? Oh, just a minute. I think. Okay, I think we need to change a lot here now because Scrum Master, whenever a player is implemented, let me show it. You get data for gun. It need to return actually. Get data for gun. It need to return some value. So wait. My God. If you look at get data for gun, you can see outputs. Not inputs. I'm adding inputs actually. So that interface should return values, and I need to call it and it need to return actually. So what do I need to do? We need to, we cannot have multiple return types here. So we should be having a structure, I think so, and the structure will take care of that. So multiple return types, Unreal Engine, C++. What was no actually is C++ remember to determine whether the written values are blueprint functions multiple written values actually C++ reference parameters to determine what the return. For instance, this thing function you can blueprint will treat it as in parameter conversely. The reference is constant. The reference is not constant. You can modify it in the functions of blueprint assumes is the intent and treats it as out from contained from there you can have multiple. Oh, got it. Okay, they are using ampersand sometimes and asterisk. Okay, got it. So we have to use ampersand here, I think so, because you are passing these values like f bar. We're using rotator effector for classes. We should use them, I think so. I don't know. We have to see. Maybe this is the error. We will see. It is failed. Missing hash is expected in pointer type. I need to do some tutorial, I think so, man. I'm not able to find anything. So these are the values, right? Let me make it wired, baby. Failed. Why would I get to play it? Already I'm wrong. She's not playing. My god, this is taking so much time. It is a good exercise actually. I'm doing something new. You enter. I added this function already. Oh, when everything active you can then create an event over related to the class. Oh, got it. Blueprint callable interface functions. To make a blueprint window, you must provide a U function maker and the function's declaration with the blueprint callable specifier. Blueprint callable with a new function. Got it. You must also say the blueprint implementable and must not be virtual. Public U function. Bool function. Blueprint callable can be called as a blueprint in the revision of the new interface. Blueprint function. Blueprint cannot blueprint cannot be overridden but can override any blueprint class. What can be overridden any blueprint class? Okay. Blueprint native function can be implemented in C by overriding a function with the same name. Function with the same name but with a suffix implementation method. If you want blueprints to be able to implement this, then you must use blueprintable meta printable function intended to every interface function but not overridden. All other functions will be acting function marked as blueprint callable which can be able to form but not overridden. What? Okay, blueprint implementable event. Okay. Okay, let's see. Overloaded member function not found. What is this? Okay, let us try to implement that simple thing then. First of all, let's do it with bold. I think we don't need to do this. Cancel it and just get rid of everything. It should work. Initially, yes, a lot of time goes to time waste actually, but as you keep on doing it, will become much faster actually to do this stuff. Function already has a body. Which one, dude? That interview is H17. Seven. What is error? Already has a body. Oh my god, it became successful now. What is this? Interface, player data interface. So let's see. You can save it. Go to setting. Oh my god, there are so many player data interfaces. Shit. What do I do now? Does what are this in here? Just rename them. Get data. You can just rename them to BP so that it will not collide. Player data. Okay, nice. We have this function getting data. Nothing actually, it is taking nothing. If we add these things, what will happen? It is failing. Overloaded member functionality. One of the weird things is like they are not sending any parameters here. We need to look for examples where they are sending parameters. Using a valid hands. Unreal also doesn't explain about passing parameters, which is sad. Passing parameters to interfaces. Interface passing out. What is this, George? Maybe function wire chaining constant. Const is input. Floor is output. This is also output, I think so. error. Overloaded member function not found. Overloaded member function. Overloaded. Oh my god, what is going on? Now what I need to do is fuck it. Shit man. Okay. One of the weird is I shouldn't be constant here. So what should I do? Ampersand. Yes, ampersand. But it is saying ampersand stupid shit. Const. Let me give const everything and see what it will do. Const. 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 Giving const. Wait. Appropriate implementable event. Giving const everything. Failed. More function not found. As this said, I think I need to add this underscore implementation there. killing me actually, so we have to see what to do with it. I guess. I guess we will continue tomorrow then. I guess we can do some other development. I think so. This one is way too much for me actually. I need to complete these things no matter what. But I'm not getting done at anything at all. It is just giving me this stupid error. Overloaded member function not found and I played at interface. Is there any interfaces that I overloaded member function not found and I played at interface? I need to remove cons. That is the main point here. But it is not working. God. Oh my god, mosquitoes. That stupid error. It is not giving me rest at all. Man, everyone was saying this stupid thing. Unless there is something amazing here. The blueprint native event. This is blueprint native event. Okay, maybe let's see YouTube. C++ interfaces. Maybe I think it's better if you follow these tutorials.
Hey guys, Sneaky Kitty Game Dev here, and in this video we're going to actually go through and start implementing the interface. So we're going to create a basic C++ class, C++ actor, give it the interface, and create a simple interact function, and I'll show you how to call it. Now this is going to be the most basic example, and hopefully you kind of get, I guess you could say, get the gist of what you need to do once we're done. So to begin, as always, let's actually give it a proper name. So we have basically two files here. So as always, we have the .h and the .cpp. Now in my case, I got to include more stuff into mine, so I got to do for whatever reason, I guess. But in all fairness, you don't actually really need to bother with the .cpp. You really don't need to add, in my opinion, functionality to it if you don't want to, unless you have functionality that it will be consistent in the function across anything or any class that you add that function to. So that's kind of the bare bones of it. So once we have our interface made, I'll cover what these two are here in a second. Let's go ahead and make our actor. So let's open that on up, create a new actor, and let's call this one, I don't know, box that moves up. And there we go. We have our actor class now. Let's go back to our interface. Now, what are these two? So we have, you can kind of get, go ahead and make our, in my opinion, functionality to it if you don't want to do it. So I guess let's call this one tutorial, and to begin, and I'll show you how to call it. Now this is going to be the most basic example, and hopefully you kind of get, I guess you could say, get the gist of what you need to do once we're done. So to begin, as always, we create a normal C++ class, very simple, and if you scroll to the bottom, you'll see the Unreal interface. So let's select that.
Wait, there is Unreal interface. I know that. Oh shit, here is the Unreal interface. Okay, fine. So I'm going to destroy it. Can I delete it? No. Then I need to remove it from here then. Deleted. Okay, fine. Then I'll create new C++. Where's the next? Getting created interface. Create class. Create class. I'm trying to see if it comments properly or not. Just do this stuff. Go to getting played data interface. We have an interface here, and we also have an interface here, and interface functions here. This is one function that I'm thinking of adding. New camera component. Okay, that's it. Okay, hashtag include found after generator.h. Failed. Okay, fuck. Same error. Get to transcript implementation not member violated interface. Okay, correct. So we need to go to the updated interface.cpp and just remove it. And then you can go to this. Whoa, now it became successful. So inheriting from the class works. Got it. Now what do I need to do? I need to go here and go to my MP soldier, getting class settings. No. Okay. Now we'll add this new thing. Getting bladed interface. Oh shit, okay. So bladed interface.h, you need to add this one. Blueprint. Oh my god. Same error. I don't know, it's giving the same error again and again. Which is kind of stupid. We'll think about it afterwards then. I'll do some other work then. Okay, let's see. Okay, it got compiled. Default touch functions, calc, mode functions, con functions, attack, focus, shoot. Got to do spawn bullet. Instead of that, we need to do spawn bullet 1 as the C++ function. So then it'll work. Now if people play,
Team match. Let's go.
This is working fine. And Gunmaster tick, actor tick is off, so cool. I think I'm not going to lose anything here. What is the one thing I need to know is maybe I can take some classes, maybe. We will see. I can complete his tutorials. His are kind of easy. Function setup, printers, improve printers, interfaces, collisions. You can do this thing actually. So let's start the
ಹಾಲಿಡೇ ಪ್ಲಾನಿಂಗ್ ಯಾವುದೇ ಬಾಲಿವುಡ್ ಮೂವಿ ತರ ಕಾಣಲ್ವಾ?
I will close this and I'll create a new project maybe. Or maybe I can use some existing project. Use this one. Why not? And we'll create a new project then. Complete C++ project. So yeah. Engine, binaries, Win64, ueditor.exe. Game, third person. Learning C++, learning C++, blueprints, scalable, mobile phone, whatever. Create project. Okay. Okay. Now let us complete this session today. It's a progress.
Hey everyone, and welcome to the beginning of a new playlist. And I just wanted to take the opportunity in this video to kind of keep it as its own standalone introduction to the entire playlist and how we're going to approach this, because this will be a little bit different to the previous content that I've made for the channel. I know that people don't like overly long intros to each video, so I'm going to try and explain a few things which will be relevant throughout the rest of the playlist, and then as I've done in the past, we'll just jump straight into videos for each topic that we're going to cover. Now, one other thing I wanted to mention for this video is in the background now I have the entire process of how I set up and installed Visual Studios 2019. I'm not going to cover that specifically in this playlist. I do have an installation guide for Visual Studios in my Cube Runner playlist, but I wanted to try and avoid doing that for every different version of Visual Studios, just because otherwise I'd be doing just that on this channel. So it's a very simple process. Everything that I've done to get a clean install working is running in the background now whilst I speak. So if you do want to know how I installed Visual Studios or just a guide for yourself, then just follow the on-screen prompts. I'll highlight the important things, and that'll kind of get two things in one video here, so hopefully that'll be useful. But apart from some of the installation bars filling up, I've recorded 100% of the process just here in the background. So if you follow the steps that I take, then you should have a working version, because you'll see the whole process going from the download, the installation, getting a project open in Unreal. This is version 4.22 of Unreal, working with Visual Studios 2019 to try and keep this up to date and relevant. So that's the process. As I said, in the background, follow that, and I'll cut out the installation bars. But other than that, that is the whole process going on there. So that's the first thing. Now, the second thing is I really wanted to discuss the approach I'll be taking in this playlist. So this is going to be a playlist for setting up projects in C++ and Unreal. We're going to be adding a lot of functionality. I'm going to try and keep these very topical. So we're going to do things like a video for line tracing, a video for a sandbox of different good. Obviously, C++ is going to be faster, although nowadays it's kind of marginal because of all of the improvements being made. But just setting everything by name and searching through the project folder hierarchy in C++ to assign references and things like that is just slower. And actually, that's one thing I've done here is I've created a project using the example rollable template provided by Epic. I wanted to kind of try and highlight where we're going to be splitting things from C++ into blueprints to get the best kind of flow of creating a project. So what we have here in the background is the rollable project, like I mentioned. Very simple. It just adds force to a ball, which will go around this map. Now, this is really good. This is all made in C++, like I've said, to the point where they do not have a blueprints folder. This is the actual C++ class which has been placed into the scene, which some people, this is, like I said, this is the part I don't understand. Some people like that approach where not even the class is a blueprintable. Now, what that means to me is that we cannot quickly and easily override things like the force at which this is being moved. So the speed of the character, the controllability of the character, all of this is hidden away in C++. So class, go back to the project, see if that feels right, play it again, and then again, it may still be too slow, which means we're going to have to come back in. They're doing this, they're using the construction helper, they're finding a ustatic mesh class, and they are hard coding this to be the ball mesh, which is rolling meshes and ball mesh. So it's finding that by name in folder structure, and then setting that, you'll see just below, it's going to set that to be the ball mesh that's created here. So we can find out where this is being applied. So set static mesh ball mesh object. So this is fine again, if you want to do it this way, you can. But now, in a use case scenario, if we imagine that we've set this up as a prototype for someone, we've been given some dummy assets just because the artist didn't have time to make the final asset, and they 2 weeks later have that available. So again, the artist will either have to know how to use C++, come into the project, find where they placed the new object in their project hierarchy, change the reference which is being made here, and again, compile and wait for that to upload. So this is the issue with a 100% C++ project, which for some reason people still seem to want to make. Now, the ideal way for me, at least, that I'm going to approach the entire playlist here is that we're going to come over to our header file when we can. We're going to expose these things as U properties, some functions, we'll probably use as U functions as well, and make them exposable into blueprints. But the ideal thing would be that we would come in, we can make this a blueprint. So if we find the class, make it a blueprint, create a blueprint class of this. Doesn't matter because I won't be using this project, so you don't need to follow along here. But the ideal thing then is that we're going to be able to come in, find the ball, we're going to change the mesh, say we want that to now be a cube, and that's so much faster than doing everything in C++. It took a few clicks. The class that we have is now a cube rather than a ball. We can place that in the world, and if the project was set up to do so, we would then be controlling a completely different character or pawn type. So this is how we're going to be approaching all of the content in this playlist. I just wanted to give a heads up on that, because obviously this is going to be a C++ playlist, and I didn't want people being shocked when they do see a blueprint classes being made, and quite a lot of things probably being done in blueprints for that reason. So like I said, functionalities and things, we're going to be using a lot of C++ here, but there will be things like this where we expose it to blueprints just because it's faster, and really that's where the benefit of using Unreal comes from, is this synergy between sharing the logic and the functionality between C++. You can do all your maths and stuff in C++, you can do a lot of the complex functionalities, and now we're going to be doing things like I said, line traces and stuff in there, and then we can pass that information back to blueprint classes so that we can get those results very easily, manipulate them, find out what's happening with them, debug through them a lot faster, and just make on-the-spot changes, which is where, again, the benefit of using Unreal comes from, is because you then get a very nice, clean, quick, and simple development process. And that's the main thing, is we want to make the end project as good but as fast as possible. So that was the third and final point I just wanted to cover, just to keep people's expectations in check, and so you know what you're getting if you're looking at getting started with the playlist. And just to really hit home on this, I just think I could quickly show actually the new pawn being used, the one where we've created a cube, doesn't really make any difference. But I was going to quickly come into the game mode and change the default class which is being controlled, and that would have allowed us to use the new blueprint version. But of course, this is done in C++ entirely, so we need to go to game mode again. And I'm guessing, yeah, so the static class is being defined here. So setting the default pawn class in the game mode C++ file. So again, if we just wanted to do something as simple as changing a pawn class, in this example we can do it now. This isn't to say the example was bad, obviously made by Epic. So it's a really good way of showing the official ways to set things up in C++. And of course, this is not necessarily the way that you do things in big projects, but it gives an example of the code. It's kind of a good way of documenting things, because it's not going to be very often that you see this otherwise, because like I said, it's just not the most efficient approach. But anyway, I'll leave that one there. That was just a second example I wasn't intending to make, but it inconvenienced me when I wanted to show a quick demo to you guys, so I thought I'd just include that as well. So yeah, that was all of the points I wanted to make. That's going to be how the playlist is going to be set up and approached as we go forward. And the next one, in the next video, I'm just going to go straight into creating a blank project, converting that to a C++ project, and then we'll get started in the second video in this playlist. Like I said, without all of this introduction and explanation beforehand, that has all been siphoned off into this video. So I'll leave that video here. As always, if you enjoy these videos or find them useful, please do leave a like and share the video around. That always helps. And of course, don't forget to hit the subscribe. Hey everyone, and welcome back. So in this video we're going to create our C++ project, and we're going to create some of the initial classes that we'll need for the project that we'll be working with for the rest of the playlist. Just a quick recap and to mention that for the playlist I'll be using version 4.22 of launcher, and this will bring us here, and for some reason close the Epic launcher in the background. With that done, you may create project. Now what C++ file the game mode into the root folder, and generally you like to drop things into public private folders. For different classes you have like a character folder structure, a game mode folder structure, and then you always have that initial game mode just kind of sat in the root folder, unless you want to play around in Visual Studio's changing the references and redirectories for C++ classes, which can be a huge headache. So it's generally easier to just start doing it this way, create a blueprint project, and then add your C++ content afterwards. Tends to be, at least for me, much easier. So what we're going to do to make this a C++ project is go to our file option. We want to go down to the new C++ class, and then we're going to create a new class. So I'm going to start off with the character that we'll be using, just because the character class has more in it. That'll give us a lot more to play around with in C++, like the movement components and things like that. So we're going to make a character class, and this is what I mean by the folder structures. You can see here we have the option for a public and a private folder. So generally when you create any new C++ class, you're given two different files. You get a .h file and a .cpp file. Now the .h file, the header, is where you're going to be housing all of the variable declarations. So you'll be creating the variables, the functions, and things like that in the header file, and then you'll be actually implementing them in the .cpp file. And the rule of thumb is that the header files can be public. Other classes can access them if they need information, if they need to find out what variables a character has assigned. But the CPP files tend to be private because other classes shouldn't be diving directly into calling functions or things like that in C++ from one class to another. So they're kept private and the headers are kept public. So to do this, first I'm just going to give the class a name. Again, general rule of thumb is that you will prefix the name of the class with the name of the project or the start of the name of the project, just in case you wanted to create something called just character, for instance. class. And because character is a class which already exists in the C++ hierarchy, it will say here that the name's already used. So if you wanted to then just call this, we'll say YouTube character, that is then fine. And that also gives you a nice naming structure for the rest of the project as well. So we'll have things like YouTube game mode, YouTube character, YouTube pawn, just so that we always know that they are our classes and there's no conflict with the names. For this one, I'm actually going to call this one YouTube character based, just because in case we make any other classes based on this one, then again we know this is our base class. Finally, I'm going to come down here, and after the path, I'm going to actually add the word characters, just so that this class is then nested in the characters folder. So again, if we make multiple different character classes, they can all go here. We already have the beginning of a nice hierarchy in the project and a nice structure so that we can actually quickly see where things are going. And then I'm going to make this public just so that this gets split into the correct public-private categorization. And again, we can see this is already added the public folder here, and then just move the characters folder back a bit. Okay, so those changes made, we can now make our class. Spent a lot longer on this video explaining these things than I will on any other video, so don't worry about that. But this is just the structure that we'll take for the whole of this playlist. So now that I've explained why we're doing it, I shouldn't need to recap or recover any of this, hopefully. So apologies if that did seem a bit long-winded though, but if we hit create class, this will now start compiling and creating our first C++ class for the project, and that will make this a C++ project now rather than the blueprint project it is. Okay, so that has all done at compiling. It's created the new class for us, and now just to the Visual Studio's layout. There's so much content online for learning C++ that I don't want to go too deep into like the very basics. I think one of the best ways of learning anyway is just kind of doing things, so you'll start picking things up as we go through this. But I will cover a few of the important things. So just again to recap on what I mentioned previously, if you're not familiar with this, we have our two file types created. We have our .h and our .cpp. Generally, they're both open together when you open something from the Unreal Engine. If one of them isn't, you can, for instance, just close the .cpp. We can go to source, the YouTube folder, and we can see here this is where it's actually quite important. Although we didn't see this in the engine, we have our private and our public folders. So the C++ class, like I mentioned, is in its private folder, and the header is in the public folder. So we can toggle between these. If you want to open it permanently, we just double click this and come over here. And another really handy shortcut is that we can right click. If you're not familiar with the shortcuts, right click to get the most commonly used ones, and we can toggle between the header and code file. So the shortcut for this is quickly pressing Control K and Control O. I tend to find I use that quite a lot, and that will, like I said, just toggle between them. So nice and simple if you want to add something quickly into the header file and then go straight back over to the code file to actually implement it. So like I said, the header file is where we're going to be defining a lot of things. So we can see here, this is just the constructor. So all C++ classes will come with constructor. If you're familiar with blueprints, kind of similar to the construction script. So this is where you will define some of the basic parameters. So you can set things up for variables like the max health, the current health, and things will be set in the constructor. So that anytime you launch the game, they'll have a value ready to go. And we can see this is just the name of the class followed by the name of the class again. That's how you define a constructor function in C++. And the only thing by default they do in the Unreal files is they'll set the tick event to be true. And that's because we're also using tick functions. But this is the definition of the tick function, which again we can see in the header file. If we double click on this, we'll highlight the function name. Again, we can right click on this and we can peek, or we can go to the definition or declaration. So the definition is one that you find in the code file, and the declaration, of course, is going to be the one that you find in the header file. So again, this is just a nice simple way you can start learning these shortcuts to go to and from the two different files you have for each class. And then finally, we have the same for begin play. So self-explanatory. So the definition is one that you find in the code file, and the declaration, of course, is going to be the one that you find in the header file. So again, this is just a nice simple way you can start learning these shortcuts to go to and from the two different files you have for each class. And then finally, we have the same for begin play. So self-explanatory, same as the tick. These are override functions because these are obviously being defined in the child class. So this is a character class, which will be inheriting things from the pawn class, and that structure in the inheritance of Unreal. So these are overrides, which is always important that we are calling it the super, which is just running anything which is in the child version of begin play. The parent version of begin play, and the parent version of the tick events are being called first, and then we can add the logic that we want to happen in our tick event here. And finally, just because these are here at the moment, I wanted to mention what they are. We have our setup player input component, and this is just where we're going to be adding our bindings, our access events, and things like that will be done in this function here. And again, that's already been defined for us in the code class, so we're ready to come in and add our bindings. Now, we'll probably find that we won't be using the tick in this class, so rather than leaving this entire video with no code whatsoever, let's have a quick look at how we can get rid of the function. So what we want to do is we can come back into the header first of all. We want to get rid of the tick function. We don't need that to be declared. And then whenever you get rid of something in the header file, if you've created its counterpart in the code file, we're going to come back and get rid of that as well. We can see we've now got the red squiggly to say that it doesn't exist because we haven't defined it, and we're going to get rid of that. Now we can also, that does mean as well, we can set the B kind of a tick to be false, which means this isn't going to run the tick event at all. Just generally coding, not having the tick enabled when you don't need it is just going to add that little bit more performance. And of course, it's going to be best to try and avoid using tick where possible. And from what I can see at the moment, we can always add that back in if we find we do need it. But for a character class, we're going to be doing a lot of things on the input events and things like that, so we shouldn't need anything running constantly on tick anyway. So if those changes made, we can save that. If you're using Visual Studio, it's Control Shift and B to build this, and then we can get all of this and make sure that these changes haven't caused any errors. We'll get this output log down here. And of course, you can come up and press build and build solution here if you want it. If you're using anything else, if you're on Linux, Mac, or just using something like Visual Studio Code, then of course you won't get these options. And in which case you want to come back over to Unreal, hit the compile, and compile it in here. Again, just make sure you haven't had any errors, but something as simple as taking out a function like that shouldn't cause anything. And of course, we already saw on my version that built perfectly fine in Visual Studio, but again, get the same output log here, all comes back and that has compiled correctly. Okay, so that is very, very simple. Just wanted to get the project set up first of all. We will actually be coding in the next video. We're going to be adding our character input. We're going to be creating the class in its entirety for the most part, have it running around, have some simple camera functionality and stuff like that. So I'll leave that video here today. As always, if you enjoy these videos or find them useful, please do leave a like and share the video around. That always helps. And of course, don't forget to hit the subscribe button to be kept up to date with any of the content coming from any of the playlists on the channel. And as ever, thanks for watching, and I will see you all next time.
This is how much chocolate brands are spending on advertising this festive season. To flash
Everyone.
Okay, now it's practical time. So let's get started. So we want to add new C++ class, goodness character. Character is going to be test character. It's going to be public. So hardware will be in public and source file can be in private. And characters public, yeah. So and we're going to have public inside public characters. You're going to have your header file. We have this thing here, source, learning place, private, we have this one and we have this one. Okay, so let's see. Play override, tick, set up player input component. One thing I think we can just set the stage of max FPS to 20, and we don't want it, so we're going to keep it false. Remove the entire tick function, and we're operating it, but we're not doing it anything here, so we'll give it like that, and let's begin play. Set a player component. So yeah. What? Okay, unresolved symbol. Okay, so maybe I think I can just comment it. Done. Okay, fine.
And welcome back. So in this video, we're going to implement our character movement. Before that, there's just a couple of very simple things I want to do. So I'm going to quickly create two folders, a blueprints folder and a maps folder. We're just going to get all of the project ID stuff out of the way now as well, because it'll take a few seconds. So in the map I'm currently in, this is currently called Untitled. It's just a default map. I'm going to save this into the maps folder, and I'll call this one main. So that will just be our main map for this project. We're going to go over to the project settings. We can do all of this in one go under the maps and modes. We can leave the game mode for now. We're going to have to change this very shortly. But before that, we just want to set the entry map to be main for the editor and the game default map. So that means that now whenever we restart the project or build the site, the map that will load by default will be our main map, and we're going to start adding the gameplay in here. So the other thing you probably noticed is I've moved away from the input tab. So back in the project settings, if we go to input again, I have a bunch of axis mappings and an action mapping. So these are the ones that you're going to want to copy. I'll leave these on screen. Pause the video here. Add one action mapping called jump and assign them the buttons that you want. And you can add several axis mappings. We've got to move forward, move right, turn, look up right, and look up. And again, assign the buttons that you want. Now the important thing here is that you have to remember how you name them. So if you're going to copy exactly, just make sure that you are case sensitive, because it's the names of these mappings that we'll be using and referencing in C++. And if you name them incorrectly, then your character won't be moving. Another thing to mention is that I've taken these from the third-person template pack. So if you wanted to get these without adding them yourself, I basically just created the third-person template on the Epic Launcher, went into the project, I exported the button config, so you can say export, select where you want them to export to, and then import them into another project, and you can import from that file all of the mappings. So generally something I do because I hate adding these myself, and it saves a little bit of time. Okay, so if those things done, we can move back over to our C++ class. So if you don't already have it open, go back to the C++ classes folder, we're going to go into the characters folder and the YouTube character base. Now, I'll say this for all of the classes and things that we make as we go through this playlist. I will try and give as much information as possible, especially when I think it's super relevant or it can be easily misunderstood or something, but I'm not going to be approaching this from a learning how to program on your very first day type of thing, just because there's so much documentation already available for C++ and the Unreal-specific boilerplate C++ as well, and I would be into like 30, 40-minute videos if I were to explain all of the things in depth as we add them into a C++ class. If there's anything that I mentioned that I don't cover and you still don't understand, for example, we're going to leave out things like what virtual means. I've kind of touched on overrides, but if any of these don't make sense, all of this will be in the documentation. So just have a quick Google for these and you'll find what you need for really is the terminologies I don't want to go too in-depth on. Okay, so to get the character set up, we're going to need a few different things in our header class, so make sure that you're in the header class first of all. Under the public section, so we have two public sections. This is a little bit annoying, but it kind of makes sense because when we go back over to the C++ class, where you create the functions and things here, if you automatically generate them, which I'll show you how to do later, then it will put them below the one that they are above or below in the header file. So just for tidiness, in the code file, I'm going to leave the public protected and then another public section. And that basically means anything under this will be a public variable or function, which means other classes can access it. Anything under this will be protected, which means only child classes of this class can access it. And we've got another option, of course, anything under here will be public as well. And we have a third option, which is private. Now, if anything you put under a private section will be only things in this class can access it. Okay, so again, very brief cover there, but what we want to do is go back to our first public section. I'm going to add our component. So the first thing we want is a spring arm component, which we're going to attach our camera to. Remember, when we're adding these in, we're going to be putting an asterisk at the end of the component type. So this is a type that exists in the engine. The U means that it is an Unreal-specific property or component, and anything with a U before it will be automatically accounted for and collected in the garbage collection, so we won't get anything like memory leaks. So this is creating a U spring arm component, and then we want to give it a name. So the name of the variable. I'm just going to call this one spring arm comp. Now this is going to have a red line because we don't actually, this class doesn't know what a U spring arm component is yet, and we're going to fix that in a moment. But first of all, we're just then going to go back above this and create the U property. Okay, so U properties are going to be again, this is Unreal-specific C++ boilerplate. This will give it the properties which will allow it to be exposed in things like blueprints. We can do things like setting it to be only visible in blueprints, things like that. And the ones that we want for our spring arm to make it very easy to edit and update. We want to make it visible anywhere. We want to make it blueprint read only, so we can't change the type in blueprints, but it will allow us to see it. And then finally, we're going to give this a category name, just so that it nests things in a nice tidy way in the editor. And in this instance, I've just called mine category camera. Now, there are different ways that you can do this, just to highlight that you may see this in different ways. You can do it without the double quotes, and I think you normally see it like this. It'll be category equals and then immediately after the category name. I just kind of like the look of having the quotes and that little bit of separation. Okay, so the final thing is we want to get rid of our red squiggly. So the reason we have this is that the class at the moment doesn't know what the spring arm component is. It doesn't exist in the libraries that it references, because we're using this new thing, which is the core minimal, which is an update which was made probably 4 or 5 versions ago now. And it just means that we only include what the class absolutely needs to begin with. It cuts down and compile times, it means it doesn't have as many references to different classes to worry about, but it does mean we now have to manually add the things that we want to use. Now, there are two ways to do this. We can use the hash include, so we'll use or pound include, and then the library in which you find the component. Now, if you do it this way, this is the slightly heavier way to include things. It will have all of the references to that entire class on the assumption that you want to do things like calling functions or references within that class. Now, the slightly lighter way, and the way that you normally do this in the header file, this doesn't tend to be used as much in the code files, is you can just put the word class in front of the component. So we can say class uSpringArm component. Now, when the compiler reads from top to bottom, it will see the class and obviously left to right. It will see the word class first, and it will know that we need to make a quick reference to what the SpringArm component class is and get information about that. Now, when you're declaring something, that is the very minimum that you need, and that will work for header files. Now, another way to do this, and the way that I like doing it, just in case we ever need to add a second component or something, because this will only be valid for the component or the asset directly to the right of the word class, is we can put this underneath the includes and then class in front of it. And the way that you normally do this in So we'll use or pound include, and then the library in which you find the component. Now, if you do it this way, this is the slightly heavier way to include things. It will have all of the references to that entire class on the assumption that you want to do things like calling functions or references within that class. Now, the slightly lighter way, and the way that you normally do this in the header file, this doesn't tend to be used as much in the code files, is you can just put the word class in front of the component. So we can say class uSpringArm component. Now, when the compiler reads from top to bottom, it will see the class and obviously left to right. It will see the word class first, and it will know that we need to make a quick reference to what the SpringArm component class is and get information about that. Now, when you're declaring something, that is the very minimum that you need, and that will work for header files. Now, another way to do this, and the way that I like doing it, just in case we ever need to add a second component or something, because this will only be valid for the component or the asset directly to the right of the word class, is we can put this underneath the includes and then just close it off with a semicolon. And now that means for this header file, we can add as many uSpringArm components as we need, and it will always have at least the base understanding of what that component is. So again, these explanations are made a little bit more in-depth than I will going forward, because we're going to be doing very similar things for the other components, but the logic behind them, the whys and hows we're doing them, are all going to be the same. So that is our SpringArm component now added to our header class. The next thing we want to add is the camera to attach to the SpringArm component. So we're going to want to do the same thing again. We want our class, and then we want the camera component. And we're also going to add a static mesh, so we may as well get that out of the way whilst we're up here. So we'll say class static mesh component, and there we go. They are the three references to the classes we need to continue. So if we add a camera component first of all, and then we can add our property, and in fact this is exactly the same as this one, so we can just copy and paste. And then we want the static mesh, which will be the mesh for the character. I'm just going to use a cube for this, so we don't need to worry about things like animations, but you could obviously make it a skeletal mesh if you wanted. In fact, because we're using a character class, it will have an inherited skeletal mesh in the character class. And that's another thing. If you ever want to look at what's happening here, we can go to the definition of the header, the character class, and you can always reference how they're adding in their properties, the skeletal mesh components and things like that, so you can get an idea of how it's all being done in the engine code as well as the classes that we're making. So this is a really good way to actually get more of a working understanding of how the classes are set up behind the scenes, and of course how to set yours up based on this. So definitely if you get some time, you just want to learn a bit more, have a read through the base classes, probably start with the pawn class rather than the character class, is a bit heavy, but this will be a good way to learn how they include things, how they set the properties up, how they create functions, and things like that. So we want to add an additional static mesh because we won't be using skeletal, so we're going to say the static mesh, and we'll call it mesh comp. And again, I'm just going to copy in the property that we had. I'm just going to change the name of the category.
So let's see. So read some variables here. So variables are we also need different classes like class and mesh component. So we can use component.
From camera to player, and
properties will only have read only. So visible anywhere. It's not read invisible. Most of them are also like captain. Better to follow everywhere, I think so. Visible anywhere. Anywhere W is not capital. Better to do it there. Okay, this is also great.
And there are the components ready to go. Okay, so in the protected section now, so the things which are only going to be relevant to this class and classes which inherit from it, so which are made child classes, will be the movement, and we want a function for all of the inputs that we provided. So this is quite simple. To create a function, we say void, so it's not returning any values, it's not returning a float or a boolean or anything like that. We want one for move forward, so we'll call the function move forward. We're going to need to pass in the value, the amount in which we want to move, and that's going to be based on the input. So we'll just set this as a float value. And then again, we close that off with the semicolon. So that is how we declare a function. So I'm just going to do the same thing for the next one. We're going to have a move right, turn out rate, look up at rate as well. Okay, so the functions we'll be using in our code class when we implement the actual movement. The next thing is we can just add in our base properties as well. So this is just going to be a float for the base turn rate. If you still have the u property copied from previously, we can just paste it down because again, we want this to be visible anywhere. Blueprint read only, so we can't change the type or anything. This is specific to the turn rate of the camera, so we can leave the category as camera as well. And then we want a base look up at rate. So one of these is going to be for the controller, by the way, one is going to be for the mouse and keyboard. That's why we've got two similar things, but they will be implemented slightly different in their functionality. And again, I'm just going to copy in the u property that we've had previously because that just seems to fit quite well here. Okay, so that is our header file ready to go. Something else to be aware of is that, again, if you don't have access to Visual Studios, I'm using the community version, so it's completely free. But if for some reason you have a restriction or a system which doesn't run this, then you will be missing out a few features that I mentioned. One of which is that we can create a function quite simply by
Now I need to create a couple of functions. I like to create everything under public, so let's try it. Void. Float value. Turn up rate, turn it rate, float value, turn it. We'll also be having some variables.
highlighting the name, pressing Control and the period or the full stop button and hitting create definition of that function. Now this will automatically create this in the code file. If we click on this little promote to document button here, that will take us over to the code file and that function is just created. Okay, so that is the way I will be creating these for this project, just because it's faster and this has already taken quite a while. But I will run through a few examples here of how we can create these if you don't have that functionality. So to create a new function, really, it's quite simple. The things that we need are going to be the name of the function and the parameters which we're passing into the arguments of that function. We don't want the semicolons, we don't really want the void because we can just type that in. But if we copy the move right, for example, and then with that copied, we're going to go over to the C++ file. We're going to go below the move forward function. Like I said, we can quickly type void. Not copying that means that we don't need to worry about going forward and backwards here, because the next thing we need is the AYT character base. So we're calling the function inside of this class. Then the double colons, and then we can just paste in the move right, go down, and close these off with the brackets. So the open and close brackets, and there you have a function. So that's all this was. Like I said, very simple to implement. I'll just show another couple of examples. So we have our turn rate. So again, we'll get everything before the semicolon, ignore the void, come back in, and then we'll say void, and then the AYT character base, double colon, paste in that, and then the open close brackets. Okay, so we now have our turn at rate function ready to go. And then finally, I'm just going to do this, for those of you who do have the shortcut again, it's control, full stop or period, and then create definition. So I've just gone over twice how to do the shortcut version if you have that, and twice how to add them manually, and that's how we add a function into our code file. So looking at the recording now, without editing, this is coming in at around 20 minutes, probably a bit too long to keep people's attention. So I didn't really account for this, but rather than doing everything in this one video for just movement, I think I'll start splitting these out into header implementation, code implementation, and keep them again specific to their topic. Just hopefully so it's a bit easier for you guys to come in and out and start a video and get through the whole thing, rather than just having one giant video to go through and remember where you were. So I'll end this video here for everyone, and welcome back to another Unreal C++ tutorial. So we're going to pick up where we left previously, where we're implementing the character functionality. Last time we finished up with all of the header file stuff included, so we've got the functions declared, implemented some of the functions in the code file, but not actually given them any logic, and the same for the variables and components that are ready to go. So if we head back over to the code file to begin with, I'm going to go to the constructor, and this is where we're going to implement the components that we've created. And this is something which is really important to mention, is that even though we have declared the components here for the spring arm component, the camera component, and the static mesh component, they don't actually exist yet. If we were to compile this and load the character class, sometimes you may see some kind of reference to them, like a weird empty slot, but they will not actually be in the component section. You won't be able to manipulate and update the components themselves. So to get this working, this is one thing that we do absolutely need to do in C++, and there's no kind of blueprint alternative like I mentioned previously, like swapping out a mesh. Actually getting the mesh to appear is done here. So the way we do this is if we do the spring arm component first of all, so we'll find the spring arm comp, which is what we call it. We then want to say this equals to something, so we want to actually make it exist. So equals, and the function we want to call for this is create default subobject. Okay, so we need to give this a type. So we've got the type of brackets to declare that we're giving it type, and the type is going to be the U spring arm component. So that is the actual class type in the Unreal Engine, not the spring arm comp, which is the name we gave it. And then we want to give this some text to close this off. So I've just called this the spring arm comp, and then close it off with the semicolon. I'm just seeing here that's saying that it doesn't know what that is, it's undefined, and that is just because I didn't give the name of p at the end of that one. So just rename that to spring arm comp, save that, and that should go inside. Okay. Okay, so we now have the spring arm component created. We also need to attach this relative to something else in the class setup. So we now want to get the spring arm comp that we just set up. So same again, and this I'm going to call a function in the component. So we use this identifier. I'm going to say setup attachment. I'm going to set this up to something called the root component. So the root component is something which already exists in the class itself. This is just the actual root component in the editor window. So if we just quickly go back over to Unreal, I'm just going to create a temporary blueprint class based on this. I'm not going to keep it, so I'm not going to name it. But as it is at the moment, the object which is the root component is the capture component. It's the highest in the hierarchy here. And this is basically, again, this is another one of those things which is set up in the parent class. So you need to go into the character class to see how that's done, and perhaps the pawn if it's set up in the actual pawn version. So I'm just going to come back and get rid of that, but that's what the root component is in reference to. Now the next problem we'll have is that we're now actually calling functions inside of the component. This, like I mentioned previously, this class doesn't know anything about those components or the functions that it has. So for the header, what we did remember is we added this forward declaration of just declaring the class, and then just that component itself. This time for the code, because we're using the function, this is where we need the slightly heavier version with more information. So we're going to use an include, and quite simply we say include, and then we want the location that this component is stored in the engine library, which is the game framework, then /, and then string arm component. And what we see here is we get the option for string arm component.h. So we want a reference to the header file, because again, remember the header file is the public file, so this is one we have access to, and this will give us the information for the functions which are available inside of this component. And there you go, you can now see that the red squiggly's gone away, and that is how we include references to other classes. If you don't know, obviously over time you'll start learning these, but if you're just getting started, you don't know where you'd find that or how you would know that. Really, the easiest thing I found is, unless you've got certain tools like Visual Assist, quite hard to dive into the library and find out exactly where this is. So simply go to Google, type in C++ string arm component, and on the documentation at the very bottom of the page, in fact I'll show you now. Okay, so Google C++ string arm component, and feel free to spell it incorrectly with the without spaces and anything, that actually kind of helps because then it knows exactly what you're looking for. Search for that. First option, we get the API Unreal documentation. You can see the U-spring arm component, so we know that is the class that we're wanting, so it's the U-spring arm. And then at the bottom of this bit of documentation, very easy to find, we can see that the header that this class is located is runtime. Never need to include that one. Engine, don't need to include the engine. Classes, don't need to include that. So everything after classes is going to be what you're looking for in any of the classes that you're trying to include. So the important bit is game framework, which we already have, and then string arm component.h. So that's how you know how to include something. Very simple. Just go to documentation, like I said, and in all of the C++ classes, it will always be at the bottom of that page, and it's everything after the word classes that you need. You never need to include runtime, engine, or classes. Okay, so that's how we include that. And again, because I know that we're going to start adding the other things whilst we're up here, I'm just going to add the reference to our camera. So very similar process. Okay, so I actually ended up including a few extra there as I was thinking about what we needed. So I think we need these for the input components. We're going to be adding input in this video, so we'll probably need these. You can always try and comment these out if you wanted to, if you want to try and keep things as small in the references as possible. But I've got a feeling we need these for the inputs to work. We definitely need the static mesh, so components, static mesh component, and camera / camera component, so that we can have the camera and the static mesh component in a moment. But like I said, I think we will need these when we start adding in the input. So feel free to follow along and copy those in. And then if we just return back down here, we have the spring arm setup. There's one thing I wanted to show you. So again, just kind of return to what I mentioned a few videos ago. You can do all of the setup for the spring arm in code if you wanted to, but this is another one of those things where it's going to be much easier for us to do this in the blueprint class setup. So for example, one of the things if you're familiar with spring arms is you can set the length of the spring arm, and this is very simple to do here. So you can see here we get the option to set the target arm length on the spring arm component, and we simply say this equals to a value, and we can say something like 400 as the value. So that now means that when we compile this, the spring arm will be a default length of 400. Now sometimes it's just fine, you can set these up as like default values knowing that they're going to be overridden anyway, but this is another one of those things where I don't really see the value in this because these components will always come with a default value in there. There's nothing that you can add in this way on a component that will break it if you do not define it with a default value. However, it's always likely that they will be updated by the designer or yourself in the future when you're tweaking and playing with things, and this is another thing that you don't want to come back in repeatedly and compile the project every single time you just want to change the value from 400 to 500 to 600, testing out different values. So I'm not going to include this, that was just an example of what you can do, but anything that you can do in blueprints in the editor to manipulate the spring arm with the cameras, you can always call a function relevant to that in C++ as well. But this is what I mean. In this project, we're just going to set up the very bare minimum in C++, at least when it comes to design-oriented things. We can try and do most of the functionality in C++, but when it comes to design and quick tweaks like that, we're going to leave that for the blueprint class. So we're going to move on to the camera component, so we'll set that up in the same way. So I won't give this too much time because it is very, very similar. Okay, so just to recap now that's done, the same thing here. So we created the default sub-object so the camera actually exists in the editor window, and then we set the attachment. This time rather than the root component, we've attached it to the spring arm component, which is just a standard setup. So you create spring arm and then you attach a camera to it. So we can attach this. This setup attachment doesn't always need to reference the root component. You can attach it to any other existing component that you've specified in the C++ class here. Okay, so again, with the mesh component, we're doing the same thing, creating the default sub-object, and we are just attaching this one back to the root component again, which will be, if you remember, the capsule glider, so that the static mesh will sit inside of the capsule glider. Now, the last two things we want to do in the constructor, we're going to set a default value for the base turn rate and the base lookup rate. Because these variables that we make, if people did forget to implement these, then they're going to be left to 0, and it can confuse people why you're not looking around. So this is one of those times where I'd say just giving a default value over not can be the preferred approach, even if that does get updated quite often by the designer. So we'll say base turn rate equals 45, and we'll give the same to the base lookup rate as well. Okay, so just thinking about it now, says that's undefined, which means I probably spelled that wrong in the other folder, the file. So base lookup at rate. So we'll just get that version, put that in there. Okay, so just make sure we spell those correctly. Now the other thing I just realized we probably won't be using the gameplay because we're setting these variables on the constructor. So we can go back in, just really clean this up and get rid of any functions we don't need to make sure we do that in the header file as well. And that means we can now move on to our input component. So again, I'll explain these once and then just input the rest in the background. So what we want to do for an action binding, which we only have one of, we want the player input component, and this is where we reference the names we gave these in the input section under the project settings. So we're going to get the player input component, which is the value being passed around here, so this already exists for us. We want to bind an action to this button, so bind an action to this component, sorry. And the one that we have, which is the action, is our jump button, so I just called that jump. So this is the bit which needs to be typed as it was in the project settings when you created your button inputs. And for an action, we have two options. We have the first one, which is IE_pressed, so input event _pressed. We then get a reference to this, so this class, and the delegate here, which is going to be the wrapper, which is the type of class, which will be our character class. So we need to use ampersand, and then the A character class, which is actually referencing, if you remember, parent class. This is a type of character class. And the character class has something built in by default, which is the jump function, which is under the movement component. So that's what we're calling here. Okay, so you'll notice that we haven't made a jump function, whereas for the others we will be using the functions that we've made. But for this one, we're getting the parent class, which is our A character. We're going into this because we know it's got a movement component, we know it's going to have a jump function, and we're just calling that jump function. Now I'm just going to copy this one rather than typing all of that again. And there's only a couple of things we need to change. So we still want this to be a bind action, we want this to be under jump, but this time we want to change the input event to release. Okay, so again, still referencing this, and under the A character class again, this is again just a standard, right on this type of thing in Blueprint, where once you press jump, you then want to call the stop jump function to update that tally. So if you're doing double jumps and stuff, it'll take one off of the number of jumps you have left. Okay, so we'll call it stop jumping. So that's how you assign an action. So you've got the name of the button in the project, whether it's been pressed or released, and then the function you want to call when you pressed it or released it. So this is fine for jump. If you had something like a weapon, obviously this doesn't have default functions under the character class. So instead of A character, you'd call the A YT character base here, and if we had a weapon, we'd say call the fire function, which would then relate to one of these up here. And that's what we're going to do now for the axis mappings. So again, we want the player input component. This time instead of bind action, we're going to bind axis, and then from this point it's very similar again. So the first axis we're going to bind is our move forward axis. Again, this references the next bit. The user class is ourself, so this, and this time because this is calling a function that we've actually defined ourself in the lines, and then being pressed, turning the from -1 to 1 depending on whether it's a positive or a negative force being applied. I'll leave it running in the background so you can see the implementation, but there's not really anything to explain past what I just have. Saying that, I just realized that for the turning of the character, it's actually going to be best to use the pawn class. So again, when it comes to hierarchy, the class that we've made is a child of the character class, as we've looked at a couple of times. The character class is a child of the pawn class, which means the pawn class has some information in there that we can use as well. So we're going to do that here. So when we're turning, we want to reference the A pawn, and we want to call the function which is based on the controller class, which is add controller your input. And this just means we don't need to add any specific functions for the camera rotation. We can just set the camera to inherit the rotation of the controller, which is a very standard thing to do, and that's how we do that in C++. So I just wanted to break back in to mention that because it's I forgot that we'd be using that. So we do the same thing for the look up. We're going to call the character class is a child of the pawn class, which means the pawn class has some information in there that we can use as well. So we're going to do that here. So when we're turning, we want to reference the A pawn, and we want to call the function which is based on the controller class, which is add controller your input. And this just means we don't need to add any specific functions for the camera rotation. We can just set the camera to inherit the rotation of the controller, which is a very standard thing to do, and that's how we do that in C++. So I just wanted to break back in to mention that because it's I forgot that we'd be using that. So we do the same thing for the look up. We're going to call the pawn again, and this time, rather than your, we're just going to change this to add pitch input. Okay, but with that done, the last two are going to be just using the functions that we've made again. So I will go back to doing that. Okay, so the last two are for the turn rate and the lookup at rate, which is just calling the turn rate and lookup at rate functions. The reason for that is that these are going to be for controllers, and that just works slightly different to the mouse, whereas we can get the direct value of yaw and pitch input for those. Doesn't quite work the same for controllers, so we've got our own functions just to make sure that this works nicely. Okay, so I am recording this whilst I'm actually going through and editing the video. This tutorial ended up as well over 30 minutes, and this video has obviously gone over the 15p and pitch input for those.
So let's get started. Let's complete these things. We can. I'm just doing it. Just creating some components.
doesn't quite work the same controllers, so we've got our own functions just to make sure that this works nicely. Okay, so I am recording this whilst I'm actually going through an editing video. This tutorial ended up this isn't. I'll leave this one here for today. As always, if you do enjoy the videos or find
Okay guys, I think I will take some break now. So bye.